Okay, class, picking up where we left off, we're on problem number 19 now. Now, we have to simplify the complex fractions. So we could rewrite this as a division problem. This will become 7/15 divided by 7/9. Now, this leads us to this here. The first fraction stays the same, division becomes multiplication, and we take the reciprocal of the second fraction. Now we simplify. We do the prime factorization. We add 7 times, 7 is prime, and we do the prime factorization of 9, which is 3 times 3. And then we go to our denominator. The prime factorization of 15 is 3 times 5, and we'll bring over our times 7 because 7 is prime. Now, we go through and simplify. We add 7's in common, and we add one set of 3's in common. And for our numerator, we will have 3, and our denominator, we will have 5. So our final answer here is 3/5. Now we go to problem number 20. Now, we will have 8 over 14. We have 8 over 14 divided by 8 over 15. 8 over 14 stays the same. Change division to multiplication and take the reciprocal of the second factor. Now, we do the prime factorization of these numbers here. 8 will give us 2 times 2 times 2, and 15 will give us 3 times 5. Now in our denominator, 14 becomes 2 times 7, and 8, we have 3 2's. Now we simplify out all the common factors. We add 3 sets of 2's here, 3 sets of 2's here. And that's it. So now we take 3 times 5, which is 15, and 2 times 7, which is 14. Now we have 15 over 14, and we can leave it as is. Now we come down to problem number 21. It says perform the operations as indicated. We have mixed numbers added together. So what we could do is this here. We could set these up vertically. We add 17 and 1/9 plus 16 and 2 over 27. Now we can find the prime factorization of 9 and 27. We can go off to the side here. 9, 27. Prime factorization of 9 is 3 times 3. Prime factorization of 27 is 3 times 9. Then the 9 becomes 3 times 3. So we will have 2 3's here, and then we will have 3 3's here. Now we find the least common denominator. We add 2 sets of 3's that match up. So we'll write each set one time. Then we'll bring down the extra 3, and our common denominator is 27. So now we're going to bring this over. We will have 17. Our denominator here would be 27. Then we have plus 16. Our denominator here would be 27. Now we have to find this numerator. Now we look at 9 and compare it to 27. What does 27 have that 9 does not? It has an extra 3. So we'll multiply this 1/9 by 3 over 3. So 1 times 3 is 3. And we know 9 times 3 gave us 27. Now here we look at 27. What does 9 have that 27 does not? It doesn't have anything 27 does not. So we'll carry over this 2. So we'll keep the 2 over 27 the same. Now we can add these fractions. 3 over 27 plus 2 over 27 is 5 over 27. And 17 plus 16 is 33. So you add 33 and 5 27s. Now we go here to B. We have a subtraction problem. Now we need to find the prime factorization of 3 and 9. I'm going to go up here to the top. We add 3, we have 9. 3 is already prime, and 9 breaks down to 3 times 3. So the prime factorization of 3 is 3. We have one set of matching 3's. We bring that down, and then times the extra 3. So our least common denominator is 9. So we're going to write this vertically. So we add 19 and 1/3 minus 8 and 7/9. Now, remember, we have established our common denominator, which happens to be 9 here. Now, we ask ourselves, comparing 3 to 9, what does 9 have that 3 does not? It have an extra 3. So we'll multiply this numerator and denominator by 3. So we have 1 times 3 is 3, and 3 times 3 is 9. Now we have here, this denominator is already 9, and we know 3 does not have anything that 9 does not, so we carry over the 7. We keep the denominators the same. Now what we have here, we have this fraction at the bottom larger than the fraction at the top. So we know we borrow 1 from this 19, and that makes it 18. Now, our new fraction, and of course we carry everything over, your bottom mixed number still would be a negative 8 and 7/9. Now, with this 18, your denominator would still stay 9. But now to find the numerator, remember I told you could take this denominator plus the numerator. 9 plus 3 is 12. So it'll be 18 and 12 over 9. So we take 12 over 9 minus 7 over 9, which is 5 over 9. 18 minus 8 is 10. So our final answer is 10 and 5/9. Now we scroll down here to 22. Now first we have to change this mixed number to an improper fraction. This will give us 33 over 5 divided by, this will give us 22 over 15. Now we'll take 33 over 5, leave that the same. Division becomes multiplication, and we take the reciprocal of the second factor. Now we want to simplify. We're going to write out all the prime factorizations of these numbers. The prime factorization of 33 is 3 times 11. The prime factorization of 15 is 3 times 5. Now we come to our denominator. 5 is already prime, and 22 prime factorization is 2 times 11. Now these 11s simplify out. These 5s simplify out. Now we add 3 times 3, which is 9, and our denominator would be 2. But since our problem started with mixed numbers, if we could make our final answer a mixed number, we're supposed to. So 9/2 is an improper fraction. So we'll take 2 and a 9. 2 goes in a 9 4 times. 4 times 2 is 8. And we have a remainder of 1. So our final answer would be 4 as the integer. Our denominator would stay 2. And our numerator would be the remainder. So our final answer here is 4.5. Now we go to B. The same as division we do for multiplication. You must change these mixed numbers to improper fractions. So this will give us 22 over 5 times, this will give us 15 over 7. And just as a refresher, we keep our denominators the same, and then we would take 4 times 5 is 20 plus 2 is 22. 2 times 7 is 14 plus 1 is 15. Now we could do the prime factorizations. 22 prime factorization is 2 times 11. 15's prime factorization is 3 times 5. And our denominator 5 and 7 are both prime. So now we simplify out the common factors, which happens to be 5's here. So now we have 2 times 11, which is 22, times 3 is 66. And our denominator is 7. Now we could still make this into a mixed number. So we would take 7 into 66. 7 goes into 66. It had to be 9 times. 9 times 7 is 63. And we have a remainder of 3. So our final answer, 9 would be our integer. Our denominator would still be 7. And our numerator would be the remainder of 3. So our final answer is 9 and 3/7. Now we scroll down here to 23. Now we have a combination problem here. We have to remember our order of operations. We have addition and division. we know we do division first. So we would take this 6 1/3 and make that into an improper fraction. That would give us 19 over 3 divided by, and we'll make this 4 over 1. So this would be 19 over 3 times 1/4. Now, the prime factorization of 19 is just 19. And we know that 3 and 4 has nothing in common with 19, so we multiply them. 3 times 4 is 12. So, this is what 6 1/3 divided by 4 gives us. But we have to bring down this 3 1/2. So we'll have 3 1/2 plus 19 over 12. Now, what we could do, we could change this 3 1/2 to be improper fraction. Let's do that. 3 times 2 is 6, plus 1 is 7. So this is really 7/2 plus 19 over 12. Now we go over here. We need a little bit more space. I just say here. So we'll write this vertically. We'll have 7/2 plus 19. It's supposed to be 19 over 12. Okay, now we've already found the prime factorization of 2 and 12. I'm going to write this over here to the side. 2 is already prime, and the prime factorization of 12 is 2 times 2 times 3. So now we have one set of 2's that match up. We write that once, and then we bring down our 2 and 3. So our common denominator here would be 12. Now we look here, we compare 2 to 12. What does 12 have that 2 does not? It has 2 times 3, which is 6. So we'll multiply this numerator and denominator by 6. 6 times 7 is 42, and 6 times 2 is 12. Now, when we compare 12 to 2, 2 doesn't have anything that 12 does not, so we'll write it as is. So this would be 19 over 12. Now we add them. 42 and 19 is 61, and that's over 12. Now we could write this as a mixed number because this is an improper fraction. So we'll take 12 into 61. 12 goes into 61 5 times. 5 times 12 is 60, and we have a remainder of 1. So our final answer here would be 5 is the integer, our denominator would stay 12, and our numerator would be 1. So it would be 5 and 1, 12. Okay, now we go here to B. I'm going to draw a little line here to separate this. Okay, now we go to B. Now we have this in parentheses. 3 and 1/3 will end up becoming 10/3. And that's squared. Times. Now we have this parenthesis. We can make this 6 over 1 minus 3 over 8. 10/3 squared will end up being 100 over 9 times. Now we have to find the common denominator of 1 and 8. Now the common denominator of 1 and 8, whenever your denominator is 1, whatever the other denominator is, that is your common denominator. So the common denominator of 1 and 8 is just 8. So let's go off here to the side and take care of this parenthesis. So our common denominator would be 8. Now, since this already has 8 as the denominator, we know we could leave that as 3/8. Now we ask ourselves, 1 times what is 8? We know 1 times 8 is 8. So we'll multiply our numerator and denominator by 8. So now 6 times 8 is 48, and 1 times 8 is 8. Now 48 over 8 minus 3 over 8 is 45 over 8. So now we'll multiply this by 45 over 8. Now we have to do the prime factorization. We've done the prime factorization of 100 before. It'll be 2 times 2 times 5, and 45 would be 3 times 3 times 5. Then our denominator, 9 is 3 times 3, and 8 is 3 2's. Now we simplify. We add 2 2's here, we have 2 2's here. We add 2 3's here, we have 2 3's here. And what we would be left with in our numerator is 125 all over 2. So now we can write that as a mixed number.